took us our second try on onion, but this time we actually did it. Okay, hair.
Howdy, hey, yo. Welcome back. It's me. Oh my goodness. My stream setup looks so bare without chat showing. Let me turn all this on for you. There we go. Howdy, hey, y'all. Theoretically, I addressed at least some of the audio things that were happening last stream. The crackling was, I was trying to turn off the post-processing that StreamYard does, but I accidentally totally borked my settings. And yeah, was getting a little bit too loud. Theoretically, I should be live right now. Just grooving. I was expecting Adam to be jumping on in here with text-to-speech nonsense. I did look at the clip that he sent me at the last stream. Just kind of grooving, waiting for people to come on in.
Yo, I I'm back.
Hey, welcome back. Long time no see. We're going to be doing, like I talked about earlier, just some Unity game dev. The original idea for this stream was really intense and really serious, and it just didn't really fit the vibe. It's still a serious topic in general, but I didn't think that I was the right person to be able to be talking about it on stream. Hey, Jeffrey. Thank you. I like the background music too. Welcome, welcome, y'all. Looks like some more people are rolling on in. The background music right now is from String Beats. Not String Beats. Stream Beats. Let's see. There we go. Closed captions got that one. So last time that we did this, let me pull up the tutorial we were following. We were following the Unity tutorial for complete beginners, which is a wonderful top tier tutorial, like probably one of the best tutorials I've ever encountered on the internet ever. So highly recommend. We're going to be following this. We were about here last time, and then we encountered some technical difficulties with dependencies on my computer that we needed to fix. Yeah, when Adam stops by, I'm hoping they stop by, I have the clip where it's younger me and younger Adam from like 2 years ago that they sent in. Yeah. We have a nice quiet chat tonight. Feel free to say things in chat. We have text to speech on, so anything that you say in chat will be read out loud. It's always fun. You can be as deranged as you want with it. But I appreciate all y'all lurkers who are here right now. Let me open up Unity. For those of you who are here now, like Jeffrey, who weren't here earlier, I was just live maybe 8 minutes ago with the wonderful Anthony, and we were playing A Fake Artist Goes to New York with chat. So I'm a little bit less prepared than I usually am because I've done back-to-back streams. Still opening everything up. Just opening up the project now. Great. This is where we were, and if it's saved, we should, hey, we have a bird that when I hit space, it flaps up a little bit higher and it falls based on gravity. Now it's just a question of really tuning it. Cat. We've given people some time to roll on in, so I'm going to go ahead and introduce myself. To those of you who haven't seen me before, hi, I'm Dimmer. I use they, them pronouns, and I'm a coach at Major League Hacking. And today we're going to be learning how to use Unity, which is an industry standard game engine, super useful for creating 2D and 3D games. There's a chance that you've probably definitely played a game that was built using Unity. It is the industry standard right now for like your more general purpose games. We've talked about other game engines before earlier this week. Oh my goodness, Jeffrey, totally. I very much support rest. We've talked about that earlier on stream. It's important for you to rest, especially on a week like Mobile Hack Week where you're doing a lot of learning as well. Oh yeah, but there are other game engines out there. Godot is an open source game engine, which is one of my favorites. But we're currently learning about Unity because they changed their licensing model to be royalty free. Whereas before they would take a % of game sales and blah, 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 where I didn't necessarily think that was the biggest deal because I wasn't planning on making any huge games, but it was just another thing to think about. Because I then, like, my license wasn't, I can create whatever I want and then just do whatever I want with it. My license specifically had like an ongoing relationship with the engine that I built it in, which wasn't really what I was looking for. So I originally learned Godot, open source, highly recommend it still, but now we're learning Unity because it is slightly more standard. And some of the things that I want to make with Unity include tying game engine sort of code in with other systems, like giving Twitch chat the ability to control a game, which is harder to do in an engine like Godot because people probably haven't done it before, where people have definitely used Unity to do that before. That being said, let's just get right into it. If we open back up to our tutorial, is Unity open source? No, Unity is a closed source game engine. It is, closed source, private company, but anything that you create with it is royalty free. And they have a free, like, hobbyist version basically and a student version, which give you majority of the features. But if you were a professional game development studio, you would be paying them like you would pay for the Adobe suite, a monthly subscription fee for access to their tooling. So we're using their free version, which is fully featured to the extent that it can do basically anything that you would ever want a game engine to do. Outside of a couple few, like if you're a huge game studio, you might need access to the source code to add things onto it because it isn't open source, it's closed source. Where we left off in the tutorial, theoretically.
So, if we mess with the flap strength and also the gravity scale on the rigid body, we'll
Let me turn that up for y'all.
hopefully get to something that feels good.
So the point here is we need to change and like mess with the flap strength and the gravity amount, which is applied here, to get the game feeling right. Because we have the code and we have the assets here. We have like the hard stuff. Now this is like the soft stuff.
Changing numbers back and forth. Honey, that's game design. Recap time. We can use code to change the properties of a component while the game is running. A script cannot talk to the other components on the game object by default. You have to make a line of communication by storing a reference to that specific component. We create the reference in code and then fill it in Unity by dragging and dropping. Code in start runs once when the script comes into existence. Code in update runs continuously every single frame. But we can use if statements to skip some code unless a condition is met. And we can use public variables to change certain values in Unity's inspector even while the game is running. Okay, so
Great. That is one of the things that I like about this tutorial is that it is assuming that you know nothing of programming. While I haven't written any code in C# specifically, which is what Unity uses, I have done enough programming to not need an introduction to if statements, but I appreciate that it's there for people who don't have that experience. Just clearing up my windows. Great. This is the code that we have thus far. It's why I feel comfortable jumping in halfway through the tutorial with y'all, because really all that we've done is we've added the piece of code that when we hit space, the bird goes up, and we've added gravity to it, which was in the engine itself. We've literally written maybe 3 lines of code. So C# and Jeffrey is like, I don't want to say it's an unused language, but its utilization is fairly infrequent. Game dev is probably the most current use of C# that I've seen. C# is kind of out of date, I would say. Maybe that is something that I'll be proven wrong. Maybe someone in chat uses C# every day and it's their favorite language. But in general, C#'s kind of fallen by the wayside. Let's try Changing some settings. Whoa, okay. I increased the gravity scale to 3, and that was way too much. Let's try this again. Two feels nicer. What if we change it to 2.5? That feels Flappy Bird-esque. .5 is too much. Let's try 2.25. Yeah, that feels good. Let us continue the tutorial.
The secret to Flappy Bird is that while it looks like a bird is flapping along through a world of pipes, it's actually not. The bird stays completely still, and it's the pipes that move across the screen. So in step 3, we're going to make pipes spawn into the world, move across the screen, and then delete themselves. We'll start by making the object we want to spawn. This will be 2 pipes which move across the screen from left to right. Let's make another game object called pipe. Put it exactly on the bird for now to get the sizing right. And then we'll make another object within this one called top pipe. This is a child of the first game object's parent. This way we can nest multiple game objects and move all of them at once just by moving the parent. So let's repeat what we did for the bird. Add a sprite renderer for the pipe image. And add a collider, a box collider 2D this time. We don't need a rigid body because it's not going to be affected by physics. We can then move it up above the bird, but keep the X position as 0. Finally, we can duplicate this whole top pipe object, call it bottom pipe, and flip it upside down by changing the Y scale to -1. Then move it down below the bird.
Great.
As you can see, if we mess with the pipe parent game object, both pipes move, scale, and rotate along with it, with the parent as the pivot point.
Jeffrey, I also did too before I got into game design. It's interesting the way that all motion is just an illusion, and how we mess with that illusion results in our games.
Hello, Adam.
So let's add a script
Hey, Adam is back. Hello, hello.
to this parent's object to make it move across the screen. We'll start by creating a variable for move speed. If we give it a number here, it will fill this as the default value in Unity, but we can always
great.
change it there later. Then we'll write code to move the object in update. Now, it would be lovely if we could just type transform.position.x and change this number directly, but no, boo, you have to change the entire vector in one go. Oh, and this time we're going to have to use vector 3 instead of vector 2 because the transform has 3 numbers. Even though we're making our game in 2D, Unity is still fundamentally a 3D engine, and so it's keeping track of the object's depth with the Z value. So, here's what we'll do.
Fascinating. Okay. I didn't realize that.
We'll take the current transform.position and then equals. We want to add to its current position, so write transform.position again, and then plus. And finally, in brackets, we'll do vector3.left times move speed.
Great. This
Back
is
in
similar to
Unity,
what we wrote.
press
for the
play,
bird.
and that's way too fast. Now you might think that you could just change this move speed variable to a really small number like 0.001, and that will work, but that's not actually the problem here. You see, code in Update just runs as often as it can. In fact, if we check the stats in Game View, we'll see the game is running at over 1,000 frames per second. Sorry, PlayStation 5, 120 FPS? Pfft, that's got nothing on Flappy Bird. And the real problem is that the game may run at different speeds on different computers, and we don't want the pipe to move faster or slower depending on your rig. Real games have actually made this mistake. In Dark Souls 2, weapon durability was once tied to frame rate, so your swords would break twice as fast at 60 FPS compared to 30 FPS. That was a whoopsie. Luckily, it's a pretty easy fix. We just multiply it by time.delta time. This ensures the multiplication happens the same no matter the frame rate. We didn't need it for the velocity code because physics runs on its own little clock, but otherwise we will need it. If you want to know more,
Adam, I don't know what that means.
Silence test.
Is silence supposed to do something?
Look at her chat on screen. If I prefix with silence, it doesn't appear.
Whoa. Interesting. I'm using
Silence. Hello, this doesn't appear. Hello, this does appear.
wild. Huh. Good to know. I don't know why. The code that I'm using for that is written by Night Dev.
Little distraction, LOL.
So I'm not the one who wrote all of that code, but good to know.
About this or anything really, the Unity docs are a good place to check. You'll find info and sample code. Okay, now with that fix in place, our pipe moves smoothly across the screen. Lovely. Next, we want to create a system that will continually spawn new pipes. To start, take the parent.
So I'm going to pause and try implementing that. So the first thing that we did was we created an empty that we called pipe. And then in that, we created an empty that was top pipe. And top pipe, we added a sprite renderer. And great. And then we added a box collider 2D. We just want to make that. Oh, can we see it?
Life is wild, and I haven't left the house since Wednesday. It feels like lockdown again.
Oh, that's... Oh, golly. That's a big mood. Is that why you've been sending all of the Twitch clips from when we were in
Because of a bit
lockdown?
of snow, eh?
Okay. Why can I not see the box collider? Oh, there we go. Okay. Okay. So that is the top pipe. And now we duplicated this. And we renamed it to bottom pipe. And we set the scale to y equals -1. So we flipped it. Oh, wait, first. The top pipe position needed to go up. And the bottom pipe position is going to go down. Hey, look at that. Okay. And now here on the parent, we're going to add a new script. Let's take a look at it. Great. And it is opening in VS Code with all of the proper everything with it. Thanks to us actually handling all the dependencies yesterday. So we created a public float and we called it pipe speed. And it was set to 5 before. And then on update, we're going to get transform dot. Ooh, it was game. What is it? Game object dot transform? I think it was game object dot transform. Let's look. Transform dot position. Okay, I was right before. Well, not that I got the position part before, but we start with transform dot position equals transform dot position times, and we're going to create a vector 3 for a 3D vector, and we're going to grab vector left, and we're going to multiply it times, oh wait, no, we're going to add here, and we're going to multiply here times pipe speed. And then this also needs to be multiplied by time dot delta time. Let's test this. Hey, oh look. I do love how our bird falls and just like bounces and spins. Mwah. Physics systems, I think, create the best interactions. Gotta love a good physics system. But our code is running. We're caught up with the tutorial. Let's continue.
No matter the frame rate. We didn't need it for the velocity code because physics runs on its own little clock, but otherwise we will need it. If you want to know more about this or anything really, the Unity docs are a good place to check. You'll find info and sample code. Okay, now with that fix in place, our pipe moves smoothly across the screen. Lovely. Next, we want to create a system that will continually spawn new pipes. To start, take the parent game object from the hierarchy and drag it into your project. This creates a prefabricated game object, or prefab. This is like a blueprint for a game object, and we can create new
So we dealt with prefabs on Wednesday when we were working with the micro game that they had set up. But I'm curious. I feel like I've... Okay. I missed that.
smoothly across the screen.
Great.
Lovely. Next, we want to create a system that will continually spawn new pipes.
Yes.
To start, take the parent game object from the hierarchy and drag it into your project. This creates a prefabricated game object, or prefab. This is like a blueprint for a game object, and we can create new versions of this entire game object with all of its children, components, and properties. Oh, and before we move on, we can delete the original in our hierarchy now. Bye-bye. Let's make a new game object called Pipe Spawner. We'll put it just to the right of the camera, and we'll make a script for it. The purpose of this script is to spawn new versions of the pipe prefab every few seconds. And because the pipe already has code to move left, the pipe will automatically move across the screen as soon as it spawns in. We're going to write some code to spawn that prefab we just made, so we'll start by making a reference to the prefab. Up here, we'll type public GameObject pipe. Then in Unity, we'll use the same drag and drop method to fill the slot, but this time, instead of a component, we'll drag the prefab from the project panel. Now, Unity has a nice built-in method for spawning new game objects. We'll type instantiate and then open the brackets. In here, the command is asking for some extra details. We can actually flip through these to find different, recipes, I guess? Number 4 looks good. It will create an object at a specified position and rotation. So for the game object, we can type pipe. For position, we can just type transform.position to get the position of the object holding the script. That will make it spawn on top of the spawner. And for rotation, let's just use transform.rotation, so again, it's the same as the spawner. Let's run it, and oh my god, that's not what we want. Spawning works great, but they're coming out every single frame, and we want them to come out on a nice interval that we can control. So, back to Visual Studio. What we're going to do now is write some code to make a timer. This will count up for a specified number of seconds, run some code, and then start the count again. To do this, we'll need to make a couple variables. A spawn rate is how many seconds it should be between spawns, and then a timer is the number that counts up. We can make this one private as we won't be changing it in the editor or anywhere else. In update, we'll do another if statement. This time, if the timer is less than the spawn rate, then we want to make the timer count up by 1. So we'll take the timer as it currently is and add time.delta time to it. This creates a number that counts up every frame and works the same no matter what your computer's frame rate is. We can actually shorten this by changing it to plus equals. But don't feel like you need to make your code as short as humanly possible just to avoid getting sniffy YouTube comments. If timer equals timer plus is easier to read and grasp, then that's absolutely fine. You can always swap to the other version in the future when you feel more confident. Now, before I said an if statement is like a gate, and we can add another gate to the side of it with else. This means if the condition isn't met, then skip the code and do the code in else instead. So we'll put the spawn code in here, and also reset the timer to 0. So now every frame, it asks if the timer is less than the spawn rate. If it is, then count the timer up. If it's not, i.e. the timer has actually met or exceeded the spawn rate, then spawn a pipe and start the timer again. Put this in Unity and pretty good. I'm happy with that. The only problem is we have to wait ages for the first pipe to spawn. It would be good if this came out immediately, right? Now we could copy and paste the spawn code into start, so it happens once in start and then happens over and over in update. But that's a bad idea. You should generally try to avoid having the same or even similar code in multiple places. What happens if we want to change how the spawn works? We'll have to find and change it everywhere. No good. Instead, we can put the spawn code in a new function and just run that function. So here, below update, but above the final curly bracket, we'll make a function called void spawn pipe, and then cut and paste the instantiate code into there. Now we can just write spawn pipe with empty brackets in both update and start. This will run all the code in that function when these lines are executed. And with that done, it will make a pipe as soon as the game begins, and will make new pipes every time the timer maxes out. Perfect. However, this is a pretty boring game, right? The pipes always come out in the middle. We want them to come out at random heights. So remember that when we wrote the instantiate code, we had to pick a position for the object to appear? We'll change that value. Right now, the pipes always spawn on the same position as the spawner. We want the x value to be the same, but for y, we want to pick a random point somewhere above or below the spawner. So let's create a public variable for a height offset, maybe 10. And then we'll make a float called lowest point. Because we're making this variable inside the function rather than at the top of the script, it means it can only be used within the function. But it also means we can set it by doing a calculation. So we'll do equals transform.position.y minus height offset. And then we'll make another one for highest point, but this time it's plus height offset.
So none of this is like super groundbreaking, but it is like showing me specifically as someone who has done development before in like a traditional sense, and also some game development, using those public variables so that you can, once you write the code, you can make all the tweaks to the game feel and the game design outside of the code in your engine itself, in the inspector in this case. It's a very important thing for me to be learning and remembering right now.
Set. That gets us these two numbers. Then we'll replace the transform.position in our instantiate code. We're going to write new vector 3. We have to write that whenever we're specifying our own numbers for a vector. And then in brackets, we'll specify the x, y, and z values as 3 different floats. For x, we want this to be the same as the spawner, so we'll do transform.position.x. But for y, we can do random.range, and in the brackets for that, we can supply a minimum and maximum point to pick from. That's lowest point and highest point. Then a 0 for z, and close the brackets. Back in Unity, nice! The pipes will spawn anywhere between these two numbers. Oh, random.rain.
Okay.
And in the brackets for that, we can supply a minimum and maximum point to pick from. That's
Random.range
lowest
is
point.
shockingly like humanist in its approach. I was expecting something more like a Java or a Python where you are more explicitly needing to set that range.
And highest point. Then a 0 for Z, and close the brackets. Back in Unity, nice! The pipes will spawn anywhere between these two numbers. Oh, one last thing. Every time these pipes spawn, they'll appear and move left
We never despawn.
forever, which isn't great practice. They're off screen and doing absolutely nothing, and yet they're still in memory and running code every frame. And if too many spawn, they'll start to spill out the side of your monitor and make a right mess on your desk. So let's fix that. Now we could make a timer and delete the pipe after a few seconds. But instead, we'll check the X position of the pipe and delete it if it goes past a certain point. We'll borrow the bird to find out the X coordinate of the left of the screen. Looks about -45. In the pipe move script, we'll add a float for a dead zone, -45. And then a simple if statement. If transform.position.x is less than dead zone, then destroy the game object that holds this script.
Ooh, okay, that's convenient.
Run it in Unity and bam, they're dead. Let's do one more thing, just as a teachable moment. Just before the destroy line, let's write debug.log and then in brackets, pipe deleted. Then back in Unity, you'll see one other panel I skipped during the UI demo. It's a tab next to project called console. Then when we run the game, every time a pipe is deleted, our message is sent to the console. This is a wonderfully useful way to debug our code because we can find out exactly what the code is up to.
Okay. Now let's try writing that ourselves. We first made pipe into a prefab, and then we deleted it from here and created a new empty that was pipe spawner. Oh my goodness. I was in the game view, so it wasn't saving. Okay. Pipe. Delete. Create empty. Pipe spawner. And then in the pipe spawner, we're just going to add a script. Called pipe spawner script. There we go. Okay. So in this, the first thing that we did was we created a public game object that was pipe. And then we had another public and it was a float that was spawn rate. And then we had another one. This one was private. And this was another float that was timer. And then we had a spawn pipe function, and we used instantiate object.instantiate. What would that be? That would be pipe.instantiate. And
How's the
then,
coding going?
okay. Nothing, like, super great. Nothing
I'm
super
watching
bad.
a crime drama.
How is the crime? Wild question to ask.
It's great.
I'm glad. Are you learning a lot?
Someone stole a painting from underneath a police officer's eye.
Pretty good. I'm curious, what's the crime drama? Okay. Pipe, and then
It's called Beyond Paradise. It's the first series of a spin-off from a long-running, currently 12 seasons, show called Death in Paradise.
would you recommend Death in Paradise?
It is a fantastic show.
Okay. Okay, we need to look back at his code. Ah, okay, we do just instantiate. It's not pipe.instantiate. Okay. And then transform.position and transform.rotation. Okay, I'm annoyed at why it was highlighted there. I will definitely check out Death in Paradise. Thanks, Adam, for the recommendation. Okay. Oh, yes. We also had...
IDK
God.
where exactly you can get it in the USA, but it is well worth it. Trust me.
I mean, I have a VPN. I can go to the UK if that's what's necessary.
LOL.
Okay. I should have broken this down to smaller parts. I try when I'm following a tutorial to listen for a part and like learn and then try implementing it myself by memory. But I bit off a little bit more than I could chew.
In that case, sending you link to BBC iPlayer via Discord.
Thank you. Okay. Our update was using our timer. So if, and it was our timer is less than our spawn rate, timer plus equals time dot delta time. Else spawn pipe, I believe. And then down in our spawn pipe, our X is going to be transform dot position dot X, theoretically. And then our Y is going to be random dot range that feels wrong.
one for highest point, but this time it's plus. New vector 3. We have to write that whenever we're so we'll do transform.position and highest point.
It is range with a capital R. Okay. Is transform capitalized? I don't think it is. Yeah, it's not. Okay.
Private float lowest point.
Equal. What am I doing wrong here?
Then a 0 for Z, and close the bracket.
Oh, it's that I'm declaring it as private. There we go. Okay. Now we're adding that def code. If transform.position.x is greater, no, it'd be less than. His was negative 45. Let's check that in engine ourselves. Let's actually use negative 35. And then we destroy. How do we destroy self?
Then a simple if statement. If transform.position.x is less than dead zone, then destroy the game object that holds this script.
Oh, okay. Just game object. And also, this is an example of a thing that I should have made a public variable so that I could edit it later. Okay. That should have implemented all of the things that we just learned. Let's hit play and find out. Chances are I have done things wrong, and we're going to see. Oh, unassigned reference exception. In pipe spawner, you don't actually assign what a pipe is. And okay, let's try this again. Oh, okay. Well, we're doing some things. First of all, the pipe spawner Let's move it off to the edge of the screen. Try this again. Okay, but it is spawning constantly, which is unfortunate, and it's not randomizing. What? What are we doing wrong here? Okay. If timer is greater than spawn rate. There we go. And offset is 10. Okay, let's try this. Fix one error at a time. Nope. Still constantly running. If we forgot to reset timer equal to 0 here. That should help. Nope. I feel like it's if. Okay. For some reason, the public variables there weren't using the defaults that we gave the script. Okay, let's try this again. Okay. Well, at least it's randomizing the height, but it is not using the timer correctly. Spawn rate 5. Oh, we didn't use timer. If timer is greater than the spawn rate. Oh, no, this should be less than. Okay. I had it right the first time. Hey, there we go. This looks to me kind of like a Flappy Bird. And if we... Oh my goodness, I do like the physics interactions that we have here. Though in the original Flappy Bird, as soon as you touch a pipe, you're dead. I do think it is quite fun making myself spin. Great. Oh wait, let's check to make sure that the destruction is working correctly. That pipes are dying. Yay, a Flappy Bird! Okay, now if we pause and zoom out, hey, we can see that we have no extra pipes. Great, everything's working. Took me a sec to debug it, but we got that successfully. Let's look at the recap and then move on.
A project called console. Then when we run the game, code is up to. Recap time. Game objects can be turned into prefabs by dragging them from the hierarchy and dropping them into the project. You can then drag these into scenes. I use prefabs to create levels in my puzzle game, for example. Or you can make a spawner to instantiate new ones during the game. Timers are a great way to make code happen on a certain interval, but always use time.delta time to keep things consistent across different computers. If statements can have an else gate to make code fire if the condition is not met. You can also have else if to make more complicated gates. And you should try to delete game objects if they're no longer needed to free
Hey,
up
Wombo
memory.
Combo.
Okay, our next step is to keep track of the player's score and show it to the player on the user interface. Then we want the score to go up by 1 every time the bird goes through the pipes.
Yep.
So remember that a game object doesn't have...
So, okay, my prediction, I don't know how we're going to do the UI, but my prediction for checking to see if we've gone through the pipes is we're going to have a collider in the center of the pipe that every time the player touches, we go up 1, but we'll need then a latch so that while you're touching 1, it isn't constantly increasing. That's my guess. We'll see how it's implemented.
to be a physical thing in your game world like a character or an enemy. It can be a completely invisible manager that's just keeping track of critical data like health or time or score, and then we can make that information visible to the player using a user interface. So let's start by making the UI. Like everything else, it's a game object in the hierarchy. This time go down to UI and pick text, which may be under legacy. We'll need to zoom really far out on the scene view to actually see the UI. To make sure the UI looks the same on every device, we'll pick this new canvas game object and set the canvas scaler component's UI scale to scale with screen size, and choose a sensible reference resolution. I'm going to use 1080p again. We can then move our text around. You'll notice that UI has a rect transform rather than a normal transform. The most important thing to note is that you don't really want to mess with the scale of elements, instead change the width and height.
Yeah.
I'll then increase the font size and set the default text to 0, and then check it all looks nice on the game view. Okay, now we want to make a script that will
So I'm a little bit confused right now because I don't see our bird and our camera. We might just be looking at our canvas. I forgot that we created a canvas first. Okay, let's continue.
store the player's score and change the number on the UI to that score. We'll make a game object called Logic Manager, and we'll give it a script. This script is going to keep track of high-level information like the player's score, and it will have various meta-level functions that we can run. So we'll delete start and update. We don't need them in this script. We can always add them back later if we change our mind. We want to store a number for the player's score. This time we don't want a float because we only ever want round numbers. So let's do an int instead. That's an integer, no decimal places. And because we want to update the UI text we just made, we will, as always, have to make a reference to it. Except text doesn't seem to be a thing. Well, by default, a script only loads in stuff you need for basic Unity functionality. But if we go up to the top and type using unityengine.ui, we can now access more functionality, in this case, UI stuff. Now we can make a reference to text. We'll need to drag the text component into this field back in Unity. Because we're referencing a component on another game object, the text on the UI, the best way to do this is to just drag the whole game object into our slot. This will automatically find the text component for us. Handy. So now we want to make a function, and we'll call it addScore. And because we're going to run this function from other scripts, we'll set it to public void. This function needs to do two things. Add 1 to the player's score. Easy enough, we know how to do that now. And change the text on the UI to be this number. The text box is looking for a string, a sequence of characters, and our score is an integer. They look identical to us humans, but robots are fussy. Easily fixed, mind you, by adding .toString to the game score. To make sure this works, let's give ourselves the power to run this function from Unity itself. All we need to do is write context menu and a name above the function.
Came back to check in and say hi.
Hi again. I'm curious what this context menu is going to allow us to do.
Now in Unity, while the game is running, hit the little dots on this script and pick the function. Nice.
Oh.
This sort of thing comes in real handy for testing.
That's incredible.
Okay, so now that we know the function runs, we specifically want to run it when the bird goes between the pipes. And the way to do this is collisions. Now, if two objects have colliders, they will bash into each other. In fact, in our game, the bird will already crash into the pipes because we've added colliders to both. However, you can also have invisible colliders called triggers. They don't create an actual collision, but they do let you know that two objects have touched and you can run code at that moment. So we're going to put a trigger in between the pipes so we know that the bird has passed through them, and then at that moment we'll run add score. Let's open up the prefab for the
this does
pipes.
look pretty
We'll make
cool.
another game object called
We're getting there. We have another 11 minutes of like real-time tutorial of video to watch. I'm pretty happy with it thus far. That does remind me, I'm going to pause and take like a smaller bite. So let's try replicating what we have. So we created a...
He'll let you do some tutorial and he'll watch some crime drama.
Enjoy your crime. UI canvas. I created an event system as well. Is that? Okay. It created that in his as well. So, and then in our canvas, we are going to create UI text. Let's use legacy text because I don't know what Text Mesh Pro actually means. Okay. If we zoom way out, we can see our canvas there. Yeah, okay. This is... I didn't understand this when we were looking at him before either. I still don't understand it now. Our canvas is scale with screen size 1920 by 1080. And then in our text, let's bring it up to the corner. Greatly increase the font size. Great. Okay. I don't remember if that's actually how he did it. Let's look back.
object in the hierarchy. This time go down to UI and pick text, which may be under legacy. We'll need to zoom really far out on the scene view to actually see the UI. To make sure the UI looks the same on every device, we'll pick this new canvas game object and set the canvas scaler component's UI scale to scale with screen size. And choose a sensible reference resolution. I'm going to use 1080p again. We can then move our text around. You'll notice that UI has a rect transform rather than a normal transform. The most important thing to note is that you don't really want to mess with the scale of elements, instead change the width and height.
Yes.
I'll then increase the font size and set the default text to 0, and then check it all looks nice on.
Okay. He just went through that really fast. There we go. Okay. Great. Now we created a new empty that was our logic manager. And then we added a new script. cleared. We didn't have anything in there, but we did import using Unity engine editor engine internal dot just engine dot UI. Great. And then we created a public text that is our like text display. And then
Beyond Paradise is available on BritBox in USA.
hey, thanks. That'll be useful. Maybe wait, BritBox? I feel like I've heard of that before. Great. Thank you.
Ew.
I really don't like how text-to-speech pronounced that one. Okay. We have our public text, and now we also want public int score. And now we create a public void update score, or wait, no, increase score. And in here, we increment score, and then we set text display equal to score. Dot to string. Cannot implicitly convert type to string. Isn't that what we did earlier?
Okay, now we want to make a script that will store the player score and change the number on the UI to that score. We'll make a game object called Logic Manager, and we'll give it a script. This script is going to keep track of high-level information like the player score, and it will have various meta-level functions that we can run. So we'll delete, start, and update. We don't need them in the script. We can always add them back later if we change our mind. We want to store a number for the player score. This time we don't want a float because we only ever want round numbers. So let's do an int instead. That's an integer, no decimal places. And because we want to update the UI text we just made, we will, as always, have to make a reference to it. Except text. We'll need to drag the text component into this field back in Unity. Because we're referencing a component on...
Okay, let's do that first.
another game object, the text on the UI, the best way to do this is to just drag the whole game object into our slot. This will automatically find the text component for us. Handy. So now we want to make a function, and we'll call it add score. And because we're going to run this function from other scripts, we'll set it to public void.
Great.
This function needs to do two things. Add 1 to the player's score. Easy enough, we know how to do that now. And change the text on the UI to be this number.
Dot text. Okay. There we go. And now, what did he do? I don't remember what he did to be able to run it through a context menu. So let's continue our tutorial.
A text box is looking for a string, a sequence of characters, and our score is an integer. They look identical. To run this function from Unity itself, all we need to do is write context menu and a name above the function.
Okay. Now, theoretically, we can test this by running. Great. We have our text increase score. Hey, it's working. Okay. Great. We're caught back up with the tutorial. I'm going to reset it back to normal speed. I had sped it up past normal speed before.
Now in Unity, while the game is running, hit the little dots on this script and pick the function. Nice. This sort of thing comes in real handy for testing. Okay, so now that we know the function runs, we specifically want to run it when the bird goes between the pipes.
Yep.
And the way to do this is collisions. Now, if two objects have colliders, they will bash into each other. In fact, in our game, the bird will already crash into the pipes because we've added colliders to both. However, you can also have invisible colliders called triggers. They don't create an actual collision, but they do let you know that two objects have touched and you can run code at that moment. So we're going to put a trigger in between the pipes so we know that the bird has passed through them, and then at that moment, we'll run add score. Let's open up the prefab for the pipes. We'll make another game object called middle, and it needs a box collider. Let's make it this sort of shape, and this time we'll tick the box is trigger. Finally, let's add a script to this new middle game object. Beneath update, type onTrig, and the autocorrect will help us type out onTrigger enter 2D. Just press tab to autofill. Anything in this function will run whenever an object first hits the trigger. There's also onTrigger exit and onTrigger stay for future reference.
Oh, so we don't need the latch that I was talking about earlier.
And it's in here that we want to run the add score function that we wrote earlier, except, once again, this script doesn't know about any other scripts in the game until we make a reference to it. So we can write public logic script logic. But back in Unity, you'll quickly realize that you can't drag the script into this slot. You can't drag it from the project panel. We can only talk to an instance of a script that lives on a game object. But we also can't drag from the scene into the prefab. That's because the pipe doesn't exist in the scene yet. It will only exist when the game is running and the spawner starts making pipes. So instead, we'll need to fill this reference using code, and this needs to happen when the pipe first spawns. To do this, we'll need to help the code find the logic script. To do this, take the game logic object and look at the top of the inspector. You'll see tags. From the dropdown,
What? Okay, this is not what I was expecting.
choose add tag. Make a new tag called, say, logic. And make sure you go back to the game object and actually set this new tag. You will forget to do this approximately 8,000 times in your Unity career, so look forward to that. Now, back in the pipe middle script, under start, we can write logic equals game object dot find game object with tag logic. This will look for the first game object in the hierarchy with the tag logic. In our case, there will only ever be one in the scene, so we know it will always find the right one, but do be mindful of that. And then we can add .getComponent logic script. So, as soon as a new pipe spawns, it will look through the hierarchy to find a game object with the tag logic. Then it will look through the object's components to find a script of the class logic script. And if it finds one, it will put that in our reference slot. It has done the exact same.
Okay. Let's do this. The first thing is we go into our pipe and we create a new empty that we call middle. And in the middle, we add a box collider 2D. Nope, not an articulation body. How do I remove this? Oh, remove component. There we go. Okay. Add component, box collider 2D.
AI.
Hey! Welcome. We're doing some Unity game development, following a wonderful tutorial. Is trigger. Okay. And now we want to make this. Not necessarily thicker, but definitely longer.
Can I ask you about this?
Yeah, feel free to ask any questions. Okay, let's make this standardized, 16 up and 16 down. Oh, nope, that needs to be negative. Libati, if you have a more, like, I don't know if this is like, hey, can I ask you a question? Or if you have a, like, if you just want me to give more context. If you have a more specific question, feel free to ask it. If not, once I'm done with what I'm doing, I can give more context as to what we're doing. Okay.
Is it possible to hack an email account? Like, do you know about that?
So two things. One, Major League hacking. Wait, are you a first-time chatter? Hey, yes, you are a first-time chatter. Welcome. Major League hacking isn't actually about hacking computers in like the I've hacked into the mainframe sense. It's hacking as in like making things that aren't necessarily designed to be perfect. Like you might hack something together with duct tape. That is the point of Major League hacking. So Major League hacking does a lot of hackathons where for 24 to 36 hours, you're writing code either by yourself or with a team to try creating something new. Like in this case, we're working on a game in Unity rather than hacking in terms of hacking into the mainframe. That being said, yes, it is possible to hack into an email account. I know about it from a cybersecurity perspective, like have a good password and turn on two-factor authentication. I don't know how to do it, and I don't especially want to. Hopefully that answers your question.
I came back to say hi, hello.
Hey, welcome back, Adam.
Crime show is going great.
I'm glad. We had a question earlier about quite literal crimes. We're just adding... I was right, by the way, Adam. I think you were here when I made my prediction. I was right with how we were doing this, so I feel smart and cool right now. Okay.
Woo to the who.
Wait, do we need to... I think we created a script here. This is where... Yes, okay. We do. Okay. Now we're adding a new tag. Logic. Great. So that when we are editing this script, no, we're looking for this script right here. We can call existing game objects with the logic tag to find them. That was the big thing that we were learning here. Okay. Oh wait, we kept starting update. Oopsie. Okay. So we had public logic. It was of type logic script. Oh. Okay. this is referring to my script, Logic Manager script, which he named just Logic script. Okay. Okay, logic equals game object at find game. Okay. Okay. Find game objects with tag logic dot what's the last part? Dot get component of type logic script. That being said, dot get component, find game object with tag, find game objects. Wait, okay. There we go. Okay. And then private void on trigger enter 2D. Wait, he was just able to use
find the logic script to make a reference to it. Except text doesn't seem to be.
We did that.
Add score. Let's open up the prefab for the pipes. We'll make another game into the prefab. That's because the pipe trig and the auto.
Okay, so this gives way more autocomplete here than what we were given. Why is that?
Correct will help us type out
snippets. Yeah, okay, we might not have snippets. Let's look for these. Hey, okay. On trigger enter. There we go. We just need the snippets. Now you should be able to on trigger enter 2D. Great. Okay, now we're caught up with the tutorial again.
on trigger into the prefab. That's logic. Tag logic. But do the hierarchy to find a game object with the tag logic. Then it will look through the object's components to find a script of the class logic script. And if it finds one, it will put that in our reference slot. It has done the exact same thing as dragging and dropping the component in the Unity editor, except it has done it instantly during runtime. Excellent. So now, the pipe's middle script can find and talk to the logic script. And if we write logic.addScore, this will run that code.
Great.
Back in Unity, hit play.
Oh wait, it's not add score. Logic dot. Increase score. There we go. Now, if we run this again, please work. Hey, our score works. Wonderful.
Play, and if we did everything right, the score will go up by 1 when we pass between the pipes. Oh, just for future-proofing and whatnot, let's make sure that it was actually the bird that went through. We'll do this by putting the bird on a layer and checking if the colliding object was on that layer. Go to the bird's game object, and this time, instead of the tag, we'll change the bird's layer. Make a new one. Remember to actually
Bird, layer. Great.
assign it and make a note of the number. Now, on the pipes middle script, we can add an if statement around add score and check if the collision that just happened was with a game object on the bird's layer. One more bit of future-proofing while we're on the subject. Go back to the logic script, and let's take the add score function, and in these empty brackets, we'll write int score to add. And then instead of adding 1 to the score, we'll add score to add. Then, in the pipe middle script, we can write a 1 in the brackets after add score.
Great.
Right now, this does exactly the same thing as we had before, but as you can surely guess, we could later add some other goal in the game that adds, say, 5 to your score. This allows us to make a function more versatile, as it can be used in different ways from different places. Part of being a good programmer, I think, is making stuff less rigid and keeping it open for future ideas. This makes it easier and faster to iterate on your designs. Right.
Okay. Let's implement those last things. If let's rename that to collision. Collision dot. I think it was get object. Oh, collision dot game object. Okay. Dot layer equals 3. Oh no. There we go. Okay. Great. Let's try this again, make sure it's all still working. It looked like it was working, but then I fell off and died trying to test something. Wait, let me just increase this first. In pipe speed, let's increase that to, let's go 8. And see how that feels. Hey, that's better. Okay, we're 1, 2. Hey, okay, it's working. Great. Let's turn that down a little bit to 7 maybe. And pipe spawner, spawn rate 7. Okay, let's continue.
Game object on the bird's layer. One more bit of future-proofing while we're on the subject. Go back to the logic script, and let's take the add score function, and in these empty brackets, a good programmer. Right, recap. UI is just another game object, but if we want to reference any of these components, we'll need to add using unityengine.ui to the top of the script. Game objects can be completely invisible things, merely there to keep track of rules, logic, score, and so on. If we want to reference a component when one of the game objects is not in the scene, we'll need to find that component during runtime. One way to do this is to use tags, find game object, and get component. A public function can be run from another script as long as you have a reference to that script, and we can even pass in variables when that function runs. And collisions and triggers can be used to make stuff happen when two objects touch. Speaking of collisions, let's move on to the next step. The final step is to add a fail state. When the bird hits the pipes, the game is over. We'll do this by making a game over screen and have it appear when the bird crashes into a pipe. The game over screen will have a button which we can use to reset the game. First, let's make that game over screen. On the canvas game object, add an empty one called game over screen. Then in that parent, add a text for game over. And also add a button that's also under legacy. Resize it and change the text on the button. The text can be found as a child on the button itself. So back on the button game object, on the button component, you'll see this bit that says on click. This is an event and it allows us to call a public function on a game object. So let's make a function for restarting the level. We can put this code in the logic script underneath our add score function. You could make a separate script if you want, but I think this is fine. Let's make another public function called restart game, and in here we'll write code to restart the scene. Just like before with the UI, if we're managing scenes, then we'll need to add a line to the top, this time using unityengine.sceneManagement. Now in our function, we'll call up the scene manager and then .load scene. This is looking for the name of a scene, literally the file name, but because we want the current scene, we can simply type scenemanager.getActiveScene brackets dot name. Close off all the brackets. Now back in Unity, add an event to this button. Then drag in the logic game object and find the restart game function. Give it a test and nice. Every time we press the button, the game begins anew. Now,
well,
obviously we don't want this to be on the screen all the time, just when we fail. So we can just take the whole game over screen game object and disable it with this checkmark. Then we'll make it show up when the bird hits into the pipes. Let's write the function first.
Okay, let's take this and implement it. The first thing is in that canvas. We are going to add a new empty that we're going to call game over screen. And then inside of this, we are going to add UI legacy text. Game over. And then we're going to add a UI legacy button. And
That episode had a big cliffhanger promo for the next episode.
bum bum
But
bum.
hi, I am back.
Hi. Play again. We're getting close. We're almost
How's
done with the game.
Codifest going?
It's going well. We are actually seemingly close to being completely done. We're on like the last piece, which is just having you actually die and restart.
Codifest LOL.
It does say that quite weirdly.
Codefest.
Oh my goodness, the lo-fi music isn't playing and I'm in the middle of thought.
That's better.
Great. Okay. Now, on our button, we have an on click, but first in our Logic Manager script, oh wait, first, using Unity engine dot scene management. We're going to create a script that is public void reset game. And then I don't remember what the actual, oh, it's restart game. That's much better. Restart game. And it was scene manager.load scene. Okay. Scene manager.load scene. Scene manager dot get active scene dot name. And then the action that happens when you press the button is restart game. Let's try this. Hey, okay, that works. This is shockingly easy, this entire process. Ooh, what's that error there?
Well done.
Null reference exception. So if I run, it's okay, but when I stop running, okay. We'll burn that bridge when we get to it.
Again, in the logic script, let's make a public function for game over. We'll need to make a reference to the game over screen game object and fill it in Unity.
Oh, fire.
And then we can simply type gameOverScreen.setActiveTrue in this function. So we want this function to trigger when the bird crashes into a pipe. Back on the bird script, let's reuse that code from before to access the logic script from the bird script. Yes, we could drag and drop the reference in Unity, but hey, we've written this code now. And then we're going to do a similar thing to the trigger code, but this time we'll use onCollisionEnter2D because the pipes are solid objects and not set to be triggers. And when that collision occurs, trigger the gameover script with logic.gameover. Back in Unity, it kind of works, but we can still play in the gameover screen. Not ideal. So, I've talked about a few key variable types already. Floats and ints are numbers, and string is usually for text. The other important one is a bool, short for boolean. This is a really simple type that is either true or false, on or off, yes or no. It's a great way to simply check or change something's state. So let's have a bool called bird is alive and make sure it starts as true. Then when the collision happens, we'll set bird is alive to false. And finally, we'll add an extra condition to our very first if statement. We're going to say if the spacebar has just been pressed and, written with 2 ampersands, and bird is alive is equal to true. Actually, we don't need to add this equals true thing. It does the exact same thing without it, but again, it's up to you. Maybe it's easier to read this with the full code written out. Anyway, now the bird won't flap if it's dead, which seems quite logical to me. The final thing to do is to build the game, which is really easy. Pick File, Build, Settings, and Build. Pick a folder on your hard drive and let Unity do its work. Then you can open this file to play your game. Amazing. In a very short period of time, we have made a pretty functional game.
Okay, wait. Before we get to that, let's actually do that ourselves. So in our logic script, public void game over. And then we also public game object game over screen. Game over screen dot active equals true. Let's set active true. Okay. Now if we go back here, in our logic manager, game over screen there. Oh, we aren't ever calling that function. That makes sense. Okay. So now we call game over from the bird itself.
The Isle of Man's bishop is set to retire. The news article by the official newspapers is titled Bishop to quit his role in the island. Clickbait. Much.
Very clickbait. Okay. If, oh wait. No, we're looking for an on collision. On collision enter 2D. On collision enter 2D. I believe we just run logic dot game over, and then let's make is live equal to true. And is alive is alive equal to false. Okay. Theoretically, this should be everything. So when we flap, we can go through a pipe. And then when we hit a pipe,
As is at least 85% of most news headlines. PSH.
we hit game over. And when we hit play again, it works. Now, yeah, I can't flap right now. Great. Okay, that worked. Right? Yeah. Okay, there are two things that I immediately am looking to change, which are in our pipe speed. Let's increase that again. Our pipe spawner, I increased spawn rate, but we actually want to decrease it. Oh, golly gee, I did that in the wrong place. Here we go. Okay, we want to decrease that, and let's try this again. Hopefully this should mean more things spawn. There we go. And we game over. That seems like a game to me.
And what's more, we've learned loads of fundamental lessons about Unity. We have made a character that moves in response to our input. We have spawned in new objects on a timer. We have created a UI that shows a score and made that score tick up when conditions are met. And we've got the ability to get a game over and start again. Now, I should note that there are different and perhaps better ways to do pretty much everything in this tutorial. For example, I used Unity's old way of checking for inputs, and the company has since developed a much better input system, but it's a lot more complicated to use, so this simple method is great for now, and you can look into the new input system later down the line when you feel more confident. That's how it went for me. There's also Text Mesh Pro, which has replaced the old legacy UI system, so you'll want to graduate to that at some point as well. Anyway, these are lessons that will be useful when making all sorts of games. But the game isn't quite finished yet. There's still a few more things to figure out, though I don't want to tell you how to do everything. So I'm going to give you some suggestions for how to finish up the game, but I want you to try and figure it out for yourself. So first of all, we need to have a game over if the bird goes off the screen. That shouldn't be too hard. There's also a bug where the score can go up even after a game over. Try to solve that one too. We also want sound effects. I want you to add an audio source component to the Logic Manager, fill it with a sound effect file, reference it on the script, and have it play when the score goes up. Then I want you to play around with the particle system to make clouds appear in the game. Next, open the animation window and add some flapping wings to the bird. Then I want you to add another scene to make a title screen, so the game doesn't immediately launch into the action. Here's a clue. You'll need to add this new scene to the build settings window. And finally, if you want a real challenge, use player prefs to save the player's high score to the hard drive and draw that on the UI as well. For each one of these, you may wish to Google the relevant terms, read the Unity docs, watch some quick tutorial videos, or ask for help in the comments down below. Next, you could expand.
Okay, well, he's giving us places to go from here, but that means that we successfully finished this tutorial.
Not done yet.
So yes, not done yet. There's plenty to go from here, but the goal was just to get this intro, and hey, look, we got the intro. We have like this game, which is working, which is amazing and wonderful. And the even better part is that he is giving direction on where to go from there, so you can practice learning on your own. That being said, I am going to drop this link in chat again, so that y'all can take a look at this tutorial on your own, because it is truly wonderful. And we finished the game at the same time that like the stream is ending, so perfect timing. Thank you all so much for coming. This has been a wonderful stream. We finished the tutorial that we started on Wednesday, and now we can use this knowledge moving forward to create things in Unity, which is truly wonderful. Let me drop.
I just had a scroll through Twitter. It was very insightful.
I'm
Thank you.
glad? Question mark. Let me drop the check-in link for you in chat. The check-in link is based on what this
HTTPS.
session was originally meant to be, but again, it got changed on the fly earlier today. So yeah, make sure you check in, get points for your guild,
Insightful,
and
more like insane.
thank you all so much for coming. I really appreciate it. Oh, closed captions were bugging out there a little bit, but yeah, this was a great stream. I hope you enjoyed it as well. I know I learned a lot, and yeah, thanks for coming, and come back later for more. What's coming up? Right after this, at 8 p.m. Eastern Time,
UK
Mara
is
is
an
doing part 3 of Build Your First Website. And tomorrow, I am running the Today in Global Hack Week. And then on Sunday, I am running 2 different streams on how to come up with new project ideas and Blender scripting for generative art. So if those sound anything interesting at all, make sure to check those out. I mean, yeah, but I've done it before, Adam. It's not that big of a deal. Check out Today at Global Hack Day tomorrow for me, and other streams coming up with Mara. Again, thank you so much for coming, and bye.